For the polynomial below, -3 is a 0. Express g of x as a product of linear factors. Well, we could use the factor theorem then. The factor theorem says if g of c for a polynomial evaluated at c equals 0, then x minus c is a linear factor. Knowing that, we actually have the remainder to be 0. So we are going to divide by the factor x plus 3. Notice our c here is actually equal to -3. So the shortcut for dividing x plus 3 into this polynomial is actually synthetic division. So even though I'm writing a division problem, I'm going to use the shortcut called synthetic division. Remember, synthetic division always works for a monic binomial, and monic means the 1 has to be a coefficient of the x here. A binomial means it has 2 terms. All right, how do we do synthetic division? Well, our c is -3, so I'm going to put -3 here. Now we're going to write the coefficients in descending order: 1, 7, 9, -9. And the first thing you want to do is perhaps draw a line here, bring down the 1, and we're going to multiply and add. Remember, all you have to do is 1 times -3 and then add it over here. So put a -3 here and add vertically. Notice you get a 4. And then you repeat this process. 4 times -3 is -12. Put it right there. And then we add. What do we got here? We got -3, and then -3 times -3 is +9. Put it there, and we add. And as expected, we were supposed to have a 0 remainder, and that 0 here is in fact this 0 there. What does this mean? What this means is that now we have actually rewritten g of x as this. G of x is one linear factor, x plus 3, multiplied to a polynomial that's 1 degree less. So that would be x squared plus 4x minus 3. And we want this in terms of linear factors. We now need to break this quadratic expression into 2 linear factors. Remember that -3 is a 0, so we're going to take advantage of that. I'm actually going to put a 0 here, and we're going to solve this equation. So if we solve this equation, we already know x equals -3. That's nothing new. But we want to do now is take x squared plus 4x minus 3 and set this equal to 0. I am actually going to complete the square here. So x squared plus 4x is now equal to this 3 over here. I need to add something to both sides and complete the square as well. So take this 4, divide by 2, we get 2, square it, we get plus 4, because 2 squared is 4. So I'm going to add 4 to both sides. And now what do we have? We have the quantity x plus 2 squared is now equal to 7. Take the square root of both sides. And now we have the absolute value of x plus 2 is equal to the square root of 7. X plus 2 is equal to plus or minus square root of 7. and we have x is finally equal to negative 2 plus or minus the square root of 7. We're not done yet. We need to write g of x as a product of linear factors. So g of x is equal to x plus 3. And in order to get linear factors here, we work backwards from here. We know that these are the zeros of the polynomial. So we are actually going to take a bracket here, x, subtract, let's say, negative 2 plus root 7. And then we'll also take an x and subtract negative 2 minus root 7. And that certainly will do it. To simplify this a little bit more, we could write the quantity x plus 3 times, what do we have here? X plus 2 minus root 7. And then x plus 2 plus root 7. And there you go. You've written g of x as a product of linear factors. Make sure you show your work as well. You definitely want to show the synthetic division. If you choose to do long division, that's all right. Notice all this work should be replicated. You definitely want to show all these mathematical procedures.